Hey everyone, we've made it to chapter 4, so we're going to do some discrete probability distributions focusing on 4.1. What we have to start with is what's called a random variable x. It represents the numerical value associated with an outcome of a probability experiment. So everything here, outcomes are numerical values. There are two types of numerical values or two types of random variables. We have discrete and continuous. In chapter 4, we'll focus on discrete, and then in the future chapters, we will do continuous. But first, let's decide what is the difference between the two. So discrete is basically, it's countable, it can be listed. So all of the outcomes can be listed. For an example, the outcomes of a dice roll, like for a six-sided die, you can list everything, 1, 2, 3, 4, 5, or 6. Right, so if I write down some things here, all your outcomes can be listed. They're countable. An example are dice. Or anytime you kind of see this term or full phrase, number of, like what is the number of push-ups you can do, right? It's whole numbers. You can list all of the possibilities, right? 1, 2, 3, 4, 5, 6, 7, 8, on to however many. Okay, now what's the opposite of this, or the other one is continuous? Continuous, you cannot possibly list all possible outcomes. So we could say cannot be listed. It's uncountable, right? Or usually you'd use an interval to describe the possible outcomes. An example of this would be, or some examples, weight, height, distance, time, things that are you'll never be able to list all possible heights, for example, right? Because you could say 57 inches or 57.5 inches or 57.53 inches. You get it? Like it's impossible to list them all because there's all those fractions between, right? So you would use an interval. Okay. So we're going to focus on discrete, and we're going to talk about probability distributions. So if I page up a little bit here, talks about probability distributions. A couple of things that we'll know is that the probability is always between 0 and 1, and that's this one. And the sum of all the probabilities is 1. So let's look at an example. Here in this example here, the following frequency distribution shows the number of televisions, so it's discrete, televisions per household in a small town. So notice here, we can list all of the possible outcomes, right? Everybody in this study had one of those 6 outcomes, 0, 1, 2, 3, 4, 5. So it's a discrete random variable. And then the households is the frequency of each of the outcomes, okay? So in this case, the random variable x represents TVs, and the possible outcomes for the discrete random variable are 0 through 5. They can be listed, okay? And let's construct a probability distribution. So this one is a frequency distribution. We're going to change that into a probability distribution. Probability distribution, you can think of that as a relative frequency distribution, like we did back in chapter 2. So when I start filling this out, the x values are not going to change. I'm just calling them x now for the random variable x. And now what I want to put for my probabilities is the probability of selecting a household that has, say, 0 TVs. So for this one, what I'm going to be doing is I'm going to take that 86 from here, and I want to divide it by the total frequency. The total frequency is if I add up all of these, right? So if I sum all of those up, I already did it ahead of time, that is equal to 1083. That's 86 plus 1058 plus 468, etc. Okay, so I'm going to take that number and divide it here, right? So I'm doing 86 divided by 1803. And I'm going to round to 3 decimal places, so I'm getting 0.048 for that one. Okay, so let me just zoom in here, 0.048. All right. The next one, I'm going to do 1,058. So 1,058 divided by that same 1,803. All right. And that's going to be 0.587. The interpretation of that number is the probability that you select a random household and they have one TV is 0.587. So close to a 60% chance of that happening. Okay. And I'm going to continue doing this. So the next one is 468. So my calculator, I'm doing 468 divided by 1,803. Okay. And that's 0.2. If I round 3 decimals, 0.260 on that one. Okay. If you want to try the rest on your own, go for it, and then you can check. I'm just going to pause now and then do them all. Okay, so that's what I got for the last three. Hopefully that looks right, and we'll continue. Okay, next we're going to find the mean of that probability distribution, and that has a specific formula for it. It's this. Looks like a lot of Greek, but that is that mu equals the sum. Right, so we have this symbol being the sum, and then this is x times p of x. So basically it's saying multiply each pair, right? And then add all of those up. Okay, so that's what I'll do. I'm gonna multiply each pair and then add them up. So that would look something like this. Mu equals 0 times 0.048 plus 1 times 0.587. This might feel familiar. This seems like what we did when we found the mean of a frequency distribution. It really what you're doing is finding the mean of a frequency distribution. And then you've got it. Okay, so I'm writing it all out here. Got to get them all. And then put that into my calculator, and let's see what we get. Okay, so that's what I came up with, 1.457, which I'm rounding to 1.5. So this means that on average, we would see 1.5 televisions per household, or probably the most common number of TVs you're going to see is between 1 and 2, right? 1.5, because you probably won't see exactly 1.5. Everybody has a whole number of TVs. Okay, for E, if you're asked to find standard deviation or variance of these, just use StatCrunch. So I'm going to jump to that StatCrunch technique to do that. So I'm going to bring up StatCrunch. Now, if you want to play along with this one, if you open up your StatCrunch, if you've already joined my groups, which I showed you how to do in the StatCrunch video, just click on my groups now, go to your summer 2020, and you should see notes, TVs, households there, and you can just load it right in. So there's the data now in a spreadsheet. Now, if you want to find the standard deviation or variance, what you're going to want to do is go to Stat Calculators Custom. Stat Calculators Custom. Okay. And this is, you're going to do this whether or not you have the number of households listed here, or you have the probability of listed here. It works for either one, which is good. So it doesn't matter how it's listed. Is it listed as frequency or is it listed as probability? Either way works with this technique. So Stat Calculator Custom. And it's a pretty simple one. The values in should be your random variable X. The weights in should be the frequency, and then click compute. Okay, now my mean, it's a little different than what we did by hand. That's because we had some rounding going on when we did it by hand. We rounded some P of X's. If I round to 1 decimal place, it's still the same mean. And then I also get my standard deviation here. So for my standard deviation, it's 0.835. Standard deviation, remember, is sigma, right? So I would use the right symbol. and 0.835. Now notice what it does not give you here. It does not give you the variance, right? So I have to calculate that by hand, but I know how to get variance if I know standard deviation, because variance is the standard deviation squared. So in my calculator, I'm going to type in 0.835, and I might go a few extra decimal places for accuracy. Heck, I might just type them all in, 0.1965, and then square, hit the square key on my calculator. Okay. And then I would take that around to however many decimal places it's asking me to. So in my calculator, I'm getting 0.697. So sigma squared is 0.697. Okay. Okay, so if I go back to the handout, I've written those down, and we can continue this page. So again, to get standard deviation and variance, use StatCrunch, the stat calculator. It'll give you the standard deviation, and then to get the variance, you've just got to take that standard deviation and square it. Now it says interpret the results for this one. We're not going to interpret the results for variance, but we will want to do an interpretation for standard deviation. And what this is, I mean, maybe this is, if I want to get a little interpretation, approximately 1, right? So on average, a randomly selected household will differ from the mean by about 1 TV. Okay, so on average, a randomly selected household will differ from the mean by about 1 TV. That's the interpretation of standard deviation. Okay, so that might come up in the homework, probably a multiple choice type thing. Okay, so there you are. We're off and running with probability distributions. Next up on the list is expected value, which I'll do in the next video. Hope the class is going well for you, and I'll talk to you later.